Good morning. So today we're looking at question 1 from the Metro Central District Common Paper, September 2021. Okay, so with regards to the first question, the question says solve for x in each of the following. So the first sum being 3x into 2x plus 1 equals 0. As you can see here, the sum is already factorized for us. Now say for argument's sake, here was a number here, a number other than 0. Okay, if that is the case, then I would have multiplied it out, brought the number over, and then factorized again. Okay, but since it's already factorized and already equal to 0, so I can then say therefore 3x equals 0. So I can divide it by 3 both sides. So x is equal to 0. Or 2x plus 1 is equal to 0. 2x is equal to negative 1. So I'm solving for x here now. Divided by 2 both sides, x is then equal to negative half. Okay, so I know also some of you can do that without going through all those steps then. Yes, we can see from here straight that 3x is equal to 0, and from there x is equal to negative half. You could have gone straight into the answer, you would have gotten the full mark there as well. A common made error by learners, what they do is they just say 3x is equal to 0 and they stop there. No mark allocated. Okay, and some reason or other they get x is equal to a half here. Okay, which is also incorrect. Alright, let's look at question 1.2. Small this down a bit. 1.1.2, it says you got 5x squared plus 3x equals 1. You must solve for x squared to 2 decimal places here. So of course we're going to use the quadratic formula. Okay, a quadratic formula here, but we need to get it in the form of ax squared plus bx plus c, which is our standard form. Okay, so we get ax squared. Ax squared plus bx plus c equals 0. We want it in that form. Why do we want it in that form? So that we can use the formula which says x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. That's the form we want it to be. Okay? So firstly we need to take that 1 over. So we get 5x squared plus 3x minus 1 is equal to 0. It's very important to now to do this question because we need to factorize a quadratic equation more than once in a paper 1. Okay, so we say x is equal to minus b, which is negative 3, plus minus the square root of 3 squared minus 4, a is 5, 1 and c is negative 1 over 2, a is 5. So we got x is equal to, or x is equal to. So we punch that into our calculators. Okay, so we then say, just get it in normal form. So it's going to be negative 3 plus the square root of 3 squared minus 4, a is 5 and c is negative 1 over 2a, 2 times 5. Alright, that gives us negative 3 plus or minus the square root of 29 over 10. Very importantly at this point is that the question says to 2 decimal places. So if you're going to write your answer in that form, you're going to lose the marks. Okay? So the answer is 0.23. So we've got 0.23. Remember that also is actually 0.24 because we have 2 decimal places. The second decimal is dependent on the third. As you can see, it's an 8. Okay? If that number, the third decimal, is greater than or equal to 5, it's going to change that 3. So to a 4. So 0.24. And for the negative solution, of course, we replace the positive with a negative. And we press SD standard decimal is negative 0.84. 0.84. Okay. Now, there's 4 marks on the sum here. We have 2 marks for your substitution and 1 mark for each solution. Now, we know some of you have the grey calculator where you can go straight from the first step, which is this here, straight into the answer. you will lose 2 marks. You will lose the substitution mark. This is the only point in the paper where this substitution in the quadratic formula has to be shown there. Okay. The next question is 1.1.3. The question says you got 3x, 3 to the 2x plus 2 plus 8 times 3 to the x minus 1 is equal to 0. Okay, now there's more than one way of doing this. I'm going to use the case substitution method. Okay, because the weaker learner understands or sees it easily if they do the case substitution method. Okay, so basically what we need to do, we need to break this up first. Okay, so that's going to give you 3 to the 2x times 3 squared plus 8 times 3 to the x minus 1 equals 0. So what happens now is that this here, 3 to the 2x, can be written as 3 to the x whole squared. Okay, and there's a 3 to the x as well. So we say let k equal 3 to the x. If k is equal to 3 to the x, we then have 3 to the x squared, which is k squared. Yes, that is going to give you 3 squared, which is 9, so it's 9k squared, plus 8k minus 1 is equal to 0. Now say for argument's sake, you don't know how to use the quadratic, you don't know how to substitute, factorize. You're always getting the signs wrong or things like that. Use the quadratic formula. It will take you a couple of seconds longer, but you would not get it wrong. Okay, because most of our students get the substitution into quadratic formula right because they do it so often and use it so often in pursuit of calculating your quadratic solutions. Okay, for those of you who have the correct calculator, we can use the factorization as well. So you got 9, 8 and negative 1. So it's going to give you an answer of negative 1 over 9 is negative. No, it's positive 1 over 9 or just put here positive 1 over 9. Or k is equal to negative 1, I presume. Yes, that's it. But what is k? K is 3 to the x. So 3 to the x is 1 over 9. So that is going to be 3 squared. So 3 to the x is equal to 3 to the minus 2. Therefore x is equal to negative 2. Well, 3 to the x is equal to negative 1. There's no way that can happen. Okay? So we simply have no solution there. So x is negative 2 there. Okay? Move to the next one. The question says solve for x and y if. So that's your simultaneous equation. You must get the simultaneous equation in your paper 1. Simultaneous equations in question 1 normally comes in at a minimum of 5 marks there. Okay, so I know the sum was 6 marks. So let's do this quickly. So from equation 1, I'm going to make x the subject of the formula. So x is equal to 2y plus 3. So let's call this equation 2 or 3. Okay, if that is equation 1, equation 2. So now we're going to substitute equation 3 into equation 2. Okay, so wherever I see an x, I'm going to put 2y plus 3. So there's an x and there's an x. So I'm going to get 2y plus 3 all squared minus 3 into 2y plus 3. And then normally the y we put at the back here. But many learners mess it up and then they multiply the negative 3 in only. So I put that y in front. Okay? So I'm going to have negative 3y into 2y plus 3. Okay, instead of putting it at the back. Plus y squared is equal to 11. Now very importantly here is that you see this binomial squared here. You see that binomial squared? Many learners make the mistake and say that it's going to be 4y squared plus 9. Which is wrong. Okay? If you are a learner who does that often, I would suggest you write this out twice. You get 2y plus 3 times 2y plus 3. And then you multiply the story out. Okay? Because many learners are making that mistake and they're losing out on the marks here. Okay? So if you do that multiplication out, multiply out there. So that is going to give you 6y squared minus 9y plus y squared is equal to 11. Multiply this out, I get 4y squared plus, that's going to give you 6y, and this is going to give you 6y is going to give you 12y plus 9, that is the mistake we made, minus 6y squared minus 9y plus y squared minus 11 equals 0. Why did I bring that over? Because I wanted in the standard form for a quadratic equation. Okay, so you've got 4y squared minus 6y squared plus y squared is negative y squared. Okay, 12y minus 9y is plus 3y. Okay, and then I got a 9 minus 11 is negative 2 equals 0. Now at this point we can divide by negative and then factorize again. However, it's when you use the function on the calculator, I know the answer is going to be 2 and 1. Okay, so again we just go negative 1, 3, whoops, so negative 1, 3 and negative 2. That gives you 2, x is equal to 2 and x is equal to 1. But not x, it's a y here. A y is equal to 2 or y is equal to 1. Now that's also a common made error, no? That learners, what they do is they use the quadratic formula and then they normally calculate it for x. So they put the x here. Okay, which also makes that incorrect. Alright. So what we do is now we substitute this back into equation 1. So we have x is equal to 2 times 2 plus 3 is 5, no, 4, 7. On the side y is equal to 2 times 1 plus 3, which is 5. Okay. People, we mark this as follows. We put a mark, give you a mark for making x or y subject of the formula, a mark for substituting it correct. Okay, so that's already 2 marks giveaway. Watch out for this here when we do the binomial square, because the learner, as I said, misses that point there. And watch out for when we multiply here. Normally they put it so that y can be at the back here. Okay, rather bring it forward. So we multiply it 1 time out. Okay, then there's a mark for getting it into standard form. A mark says 1, 2, 3, 4, 5, and together for that we gave you another mark, 6 marks. Okay, so people, this, as one of our colleagues always says, this is your bread and butter in your paper 1. Alright, Mrs. Ibrahim always says that it's your bread and your butter for paper 1. Those are the marks you must bag. Okay. In question 1.3, we are given 2x squared plus 6x minus 8. Okay. So in question 1.3.1, the question says solve for x if 2x squared plus 6x minus 8 is greater than or equal to 0. So we start off, we can go straight into critical values here. Use your quadratic equation, people. Okay. If you don't know how to factorize, use it. Alright. I would have divided by 2 and used the factorization rules as I know how to do it. So it's going to give you x squared plus 3x minus 4 is greater than or equal to 0. Trinomial. Okay, so that's going to give you x and x, 4 and 1. The 4 is positive and the 1 is negative. So you get your critical values. Those are your 0 values at negative 4 and 1. We don't say x is equal to negative 4 and x equal to 1 because that's not solutions. It's the critical value, is where the graph swaps from positive to negative. Alright? So we do it using the calculators in the way there. I'm just going to put it on this side. Okay? So we draw the. Just turn this on. Just check. Where is the calculator? Yeah. Okay, so of course we got negative 4 there and 1. So we say x is greater than 0. So this is y is equal to 0. Greater than is the power of that line. So that part there and this part there. So in other words, x must be less than minus 4 or x must be more than 1. So we say x is less than negative 4 or x is more than 1. Since there's an equal sign as well, in this case equal on both accounts there. Okay. Then let's pull this up a bit. Get a bit smaller. Now it says determine for which value or values of x will the expression, which is the given expression, be undefined. It will be undefined if the denominator is equal to 0. But hang on, I've seen that before. I've seen it here. Can you see that? So those are the critical values there. So where is this going to give us 0? At negative 4 and 1. So we got x squared plus 3x minus 4 is equal to 0. So x is equal to negative 4, or x is equal to 1. Okay. Those are the values for which x will be undefined. Okay. Then just cut the next part of the work. Okay, so in question 1.4 we are told three graphs with the formula y is equal to ax squared plus bx plus c are drawn below. So what does this tell us? It's quadratic formula. Okay. The question says match the statements below to the graph drawn. And write only the numbers 1, 2 or 3 next to each question number on your answer sheet. So the first question is, where's b squared minus 4ac equal to 14? Where do we see this? Definitely in the quadratic formula. What is that also? Your delta. So in other words, here in this case, delta is more than 0. So what does that mean? Roots are real. It has to be rational or irrational, but very importantly, unequal. Here the roots are real and equal. Here it's non-really number 2, and here it's real. As you see, what does the roots? If it's real, it cuts the axis, the x-axis. So it's real and unequal. So the first answer you have to be 3. Okay. So that one belongs to graph 3. If you're going to look at b squared minus 4ac, b squared equals 4ac. Okay. So what we need to do is we're going to bring that over the equal sign. So we got b squared minus 4ac is equal to 0. When is delta equal to 0? The roots are real, yes. Rational, yes. And equal. That is for equal roots. And the only one that has equal roots is graph 1. So b has to be graph 1. Okay. And then the last one, c, you got b squared minus 4ac, delta is negative. When is delta negative? When roots are non-real, which makes this 2. Okay. 1 mark on each there. And then the last question in this paper, question 1, sorry, is simply, just get this out. The question says, choose one of the elements A to D given below, for which is true for graph 3. Okay, I just need to get that part of the paper quickly. I know I was missing something. There we go. Sorry about this now. There we go. So choose the elements of A to D given for which is true for graph 1 and 3. So if you're looking at graph 1, what they're trying to note here is that A is negative. So if A is less than, first look at 1, as you can see the graph is smiling, so A has to be positive, so it's either C or D. But if you look at where the axis of symmetry is occurring, it's occurring at the positive part of your x-axis. So your axis of symmetry is minus b over 2a. We know that a is negative, positive, as you can see the graph has a minimum. So it's minus B, we're going to come back to now, 2, and A is negative. Not necessarily 1, but it's some value, but negative. So negative divided by negative is positive, and the axis of symmetry is positive, so this has to be a positive. So A is negative, and B is positive. So A is negative, in C A is negative, and B. A is positive, sorry, I'm missing the sum up. Let's go again. Okay? So we got minus B over 2, A is positive. A is positive, I said A is negative. So negative divided by positive is negative. But your axis of symmetry is positive. So this has to be a negative. So negative times negative is a positive. So A is positive and B is negative. A is positive, B is negative, which makes the answer C. Okay? If we look at number 3, let's use blue for graph 3. Here A is negative, as you can see the graph is frowning. So your axis of symmetry, which is the B value, is minus B over 2A. So it's negative, B we will decide on. However, A is negative. So negative divided by negative is a positive. Can you see that? Negative divided by negative is positive. But this axis of symmetry is also positive. Can you see that? So for this to be positive axis of symmetry, the B has to be positive. So A is negative and B is positive, which makes the answer B. Okay.